Lesson 7.5, solving special types of linear systems. Looks just like the work we've done so far, but, well, things are going to go wrong. We'll see how. So solve this any way you want. We'll definitely want to do elimination. So subtract down, the x's and the y's actually both cancel, so you're left with 0 equals 8, which can't happen. So that is a no solution. 0 does not equal 8. If we got something like 6 equals 6 or negative 4 equals negative 4, that would be an all solutions. Or, the way it's written in this unit, infinitely many solutions. We'll talk about that in a second. Now, the first way we solved things was graphically. The reason we did things graphically first is to help you see what these equations mean when you get no solutions or infinitely many solutions. So here's the same problem, and let's graph it. In order to do that, we've got to make some changes. So 2y equals negative 3x plus 10 divided by 2. Y equals negative 3 halves x plus 5. Y equals negative 3 halves x plus 1. So here's my two equations. Let's put them up on a graph. Put them in different colors so we can see what's going on. So up 5, 1, 2, 3, 4, 5. Down 3, 1, 2, 3 over 2. 1, 2, 3 over 2. Hopefully they line up, which they don't quite. It's because I got a curvy line there. There we go. And that's this one. The other one's plus 1. Down 3 over 2. So that's this line here. So, how can we get no solutions? Because the lines are parallel. And as we know, parallel lines never hit. So there can't be a solution. The solution of a linear system is where the two lines intersect. Parallel lines don't intersect. And that's what the answer to my next question is. How would you describe a system of equations that has no solution? Parallel lines. So, flipping to the other side. Let's set these equations up, then graph them. This one's ready to roll. And we're going to actually graph them both first. We're not going to take this advice. So, negative 2y equals negative x minus 4. Get y equals 1 half x plus 2. So go to graph. Up 2, down 1 over 2, connect the dots, and that's not only this line, it's also this line. So it's the same line. Now, if we were to solve these, we get y equals 1 half x plus 2, and then the other equation was y equals 1 half x plus 2. I'll just put negative on this one, add down, I get 0 equals 0. So that's the point I made before. If you have something equals the same thing, we know we have infinitely many solutions. Notice it doesn't mean any pairs of number works. It just means there's an infinite number of them. For example, in this one, if we put in 0, 2, that would work. That's just one solution. We could also put in 2, 4. That would also work, and so on and so on. We could also put in 2, my bad. My line is graphed wrong. Up 1 over 2. Oops. Now we got it right. But regardless, still the same line. Everything we've said is true. So there's just an infinite number of points. They just have to make sure they work. So when we have two linear equations, we have three possibilities. What are they? What do they mean graphically? Well, one solution, that means two separate non-parallel lines. And if we have no solutions, we have two parallel lines. And if we have infinitely many solutions, and I'm tired of writing out infinitely, we have the same line. Not too challenging. Pretty much the same work you've already been doing. So for example, I say how many solutions? What's the quickest way to do this? Well, personally, I would just not try and solve it. I would just move the lines about so that they look the same. So see if they're the same equation or at least the same slope. Minus x 5 by negative 2. Y equals 1/2 x plus 2. Same line. Same problem we just did, actually. So, infinitely many solutions. Notice I didn't say find any of those solutions. I just said how many they're going to be. And it turns out there's an infinite number of them. That's it. So all you have to do is pay a little bit of attention when you're doing all the work we've been doing previously with elimination, substitution, or graphing, and think about the lines. Are they parallel? Do they have the same slope? Are they the same line? Or do they just intersect once? Good luck.